step what we do. One of the things that we start this off with, and the reason why we did a factoring review at the beginning of the unit, is because the first step of everything that we do for graphing rationals is to factor. So you have to be able to factor the numerator and factor the denominator, and you have to be able to do it somewhat quickly. Now, I say that because if you're spending 5 or 10 minutes factoring, you are wasting time on your test. You will have to be able to do this rather quickly, like in a minute or two, in order to be able to factor. A lot of the time it will be an A equals 1, but some of the time it's going to be an A not equal to 1, and you're going to have to go the longer route, which means you have to be able to do that factoring rather quickly. It will really, really depend on how well you know your times tables, like what multiplies to this and adds to that. So we will start practicing some like drills to make sure that you know those values, because it is very, very important. If you cannot factor, you cannot do the rest of the problem. If it is not in factored form, that's like stopping you from doing anything else after it. So step 1 is going to be factor. There is kind of an added piece to this, and it's called a hole in the graph. So I kind of put a little H here, even though it's not really there, it's kind of there, where there are places when I don't have a continuous line on my rational function. There are instances where we are dividing by 0, and that creates something called an undefined value. And so we do not want undefined values. So we put holes in place of where they would normally be. And I'm just kind of walking through this really quickly. We are going to go through it step by step with a problem in just a second. The next thing we do is we get roots. Roots are going to come from our numerators. So I want you really big next to where it says roots. I want you to write numerator. So anytime you are trying to find an x-intercept, you need to be looking at the numerator, not the denominator. After you factor, you will set those numerators equal to 0, and we always write these as points. So the x-intercept, comma, 0. Anytime you are graphing, you must pass through a root. If it is a point on your graph has to touch it. Now, the next thing that we are going to kind of talk about are the asymptotes. We mentioned these with the rational parent function. You have a vertical, you have a horizontal. On the parent function, the vertical is normally at x equals 0, but it moved depending on how you went left or right. Now, what we're going to do for the vertical asymptotes is we are going to take the denominator and we are going to set it equal to 0, and we are going to solve. So what I want you kind of in the similar fashion, really big next to here, I want you to write denominator. So anytime you are trying to identify vertical asymptotes, you need to be doing it from the denominator of your function. And then we can go in and set each of those factors equal to 0, and we can get equations. So these are going to be just like it was in the rational parent function day, x equals some number. So we did vertical and horizontals on the parent function day. We just moved them according to the transformations. Now we're going to kind of get them from the function itself. Now, for today, you don't need to worry about the twins. We're going to spend a whole day on just tangency and togetherness later on. So we're going to kind of skip over that for now. When it comes to end behavior, we're going to kind of tackle this in different cases. There are 3 possibilities for what your end behavior could be. So one of the first things that I'm going to kind of point out before we do anything else, this is going to represent your horizontal asymptotes. And so what we need to do here is look at highest exponents. Highest, that's a bad H. We'll see. Now, and all of this that I'm kind of shorthanding in my writing is explained in detail in the paragraphs, but I want things where you can quickly look at it and you can quickly see, oh, I need to look at the numerator. Oh, I need to look at the denominator. Oh, I need to look at the exponents, so that you can kind of go through this process a little bit quicker. So there's a couple of cases that we get for exponents, and I'm talking about in the numerator and the denominator. So if it's bigger on bottom, so if I have something like y equals x2 over x3, that exponent 3 is bigger on bottom. So if that is what I'm dealing with, then my horizontal asymptote is going to be y equals 0. So if you end up with an exponent that's bigger on bottom, it's y equals 0. B-O-B-O, bigger on bottom 0. We call it BOBO. The next one is BOTSA. We're not going to worry about BOTSA today. That is another one where we're going to spend a whole day on slant asymptotes. The one that we are going to talk about lastly is exponents are the same, divide coefficients. So if I have something like y equals, let's say 2x squared over 3x squared. So notice that my exponents are equal to each other, 2, 2. So if I want to write the horizontal asymptote for this particular equation, I'm going to take the coefficients. And if you have forgotten what a coefficient is, it's the number in front of your x term. We are going to take the coefficient and we are just going to divide them. So in this case, in my example that I just made up, it just came out of nowhere. It's not anything tied to anything else. I would have a horizontal asymptote of y equals 2 over 3. So if they are the same, you just divide the numbers in front. Now, sometimes there are other things. It'll say like x squared plus 2x plus 5. Does not matter. You're paying attention to the term with the highest exponent. So that's going to be our horizontal line. So we have 3 things that we've graphed so far. We have graphed the x-intercepts that comes from the numerator. We have graphed the vertical asymptotes that comes from the denominator. We have graphed the end behavior. So that will come from, are the exponents bigger on bottom or are they the same? You will not have to worry about bigger on top yet. So you should not see anything where it is bigger on top today. And then the last thing that we graph is a y-intercept. And this is a y-intercept that you are used to seeing. All we do for the y-intercept is we go in and we plug in 0 for x. X equals 0. A lot of the time when you get the y-intercept, you can just look at the constants in standard form. So those are the numbers at the very end of our quadratic equations, because if I'm plugging in x equals 0 everywhere I see an x, the only numbers that are going to be left are the y-intercept values. So sometimes it's something you can simplify. Sometimes it's just 2 over 1 and it's equal to 2. Sometimes it's a fraction, but y-intercepts are just where x equals 0. That is where you cross the y-axis. And just like x-intercepts, you have to pass through those points. If you do not have a y-intercept, you cannot cross the line somewhere where there isn't a point there, which is going to be a big part of how do I draw the curve at the very end. So let's kind of go through this process together. And I'm going to kind of refer back to this, but I may not switch back and forth a lot. So let's go in. For example 1, do I have to do any factoring? Is it already factored? It's already factored. So I'm just going to go ahead and rewrite this as x minus 2 over x plus 4. Technically, you don't even have to do this. If it's already in factored form, great. Just for my people who need some reminders, this is my numerator on the top. This is my denominator on the bottom. couple of things that we are going to go through. And I will say this, we will present questions to you on your quiz and on your test and things like that, where we list out FRATEY. That's kind of the shorthand of what we call this. And you just have to fill in what each one of these things are. So a lot of the points for these test questions come from filling out that left-hand side, filling out what are the roots, what are the asymptotes, what are the tangency and togetherness, which we're not doing today, and end behavior and y-intercept. Most of the points, a majority, are coming from you filling out the information. So first things first, we're going to go ahead and find the roots, the x-intercepts. Remember, I said that roots are going to come from the numerator. So I'm going to go ahead and take that x minus 2 that's in the numerator. I'm going to set it equal to 0, and I'm going to get x equals 2. Now, the one thing to remember about a root is that it is a point. So I'm going to go ahead and write this not as x equals 2. I'm going to write it as 2 comma 0. And so what I will say is sometimes helpful for you guys is if you kind of stick to one color for each thing. So like all of the roots that I draw today, I'm going to draw in red. All of the vertical asymptotes I draw today, I will probably draw in green. And then my horizontals I'll draw in blue. Just to kind of give you some differentiation between all of the colors on your paper, or all of the pencil markings on your paper. So I kind of graph as I find. So I found my root of 2, 0. So I'm going to put a point at 2 comma 0. The next thing is my asymptote. The asymptote is going to come from the denominator. So I'm going to take the x plus 4. I'm going to set it equal to 0. And so in this case, this is an instance where we are writing a vertical line. So I can go ahead and write this as x equals negative 4. And before I get the question, Miss Martinez, I can look at x plus 4 and know it's x equals negative 4. Do I have to write it equal to 0? In these cases, you do not. If you can see that the denominator, you know it's going to be negative 4 when you solve it, and you just want to write x equals negative 4, that is okay. The only thing I will be careful of is if you're writing a point, it has to be written as 2 comma 0. You cannot write x equals 2. So now that I have x equals negative 4, I'm going to go to negative 4, and just like I did for the rational parent function, I'm going to draw a vertical asymptote as a dotted line. Now for us, for today, just so you have an idea, there is no tangency, so we're going to say no tan. Tangency would mean that the point, the x-intercept that you have, it touches it and it bounces back in the same direction. You're not going to see that. And we also have no togetherness. So every single time I draw my arrows, they need to be going in opposite directions. So just as some little notes for us as we start to look at graphing ahead, no tangency means we should be going through a point. You're not bouncing off in the same direction. No togetherness, if I have an asymptote, they need to be going in opposite directions. So opposite arrows. Now, I drew this picture not knowing if it's going to be an up and down. As long as they are facing opposite directions at the asymptote, that is what we want. So opposite for no togetherness. Togetherness would mean they come together and go in the same direction. We're not going to have that today at all. Okay, in behavior, if I look at my standard form, I have, and standard form is the problem that we give you, and I have x over x. So really, I'm looking at f of x equals x over x. Yes, there is a minus 2, and yes, there is a plus 4, but that does not matter. All that matters is the term that has your highest degree. Right now, I have a degree 1 over a degree 1. So is there a bigger one? Are they the same? What are we thinking? They're the same. So this is going to be, because it's a 1 and a 1, What number is at the front if you don't see a number there? 1. So I have 1x over 1x. So when I go to write the end behavior, this is a case of eats DC. Exponents are the same, divide coefficients. So what is 1 over 1? 1. So my horizontal is y equals 1. So anytime they are the same, divide the numbers in front. You don't have to write eats DC. You don't have to write the bigger on bottom 0, but you need to write what the end behavior is. And in this case, it's 1. So I'm going to go horizontal line at y equals 1. And the last thing that we have to find is the y-intercept. So again, if I'm looking at standard form, and I'm just going to rewrite it because I don't want to scroll up and down, I have x minus 2 over x plus 4. Y-intercept is where x equals 0. So all that you have to pay attention to when it comes to finding a y-intercept are the constant values. So I don't have to worry about the x minus 2, the x plus 4. I only care about the minus 2 over the positive 4. What's a negative over a positive? A negative. So can I simplify 2 over 4? What does it simplify to? Negative 1/2. So I have a y value of negative 1/2, but I'm going to write it as 0, negative 1/2. Because again, you only care about the constants. So I'm going to plot that on my paper. Now, the part that we just went through, typically after, I know this is the first one and it probably seems like what the heck was all of that. That's usually the easy stuff. The part that people struggle with is drawing the curves. So we have to put curves on the graph. You will only ever need one more curve than the number of asymptotes you have. So I have one vertical asymptote. So that means I should have 2 curves on my paper. Typically, there's going to be one on the left-hand side of the asymptote, one on the right-hand side of the asymptote. And you're kind of deciding, does it go in the top or does it go in the bottom? So in most cases, you're going to have points. We have 2 points. We have a y-intercept, we have an x-intercept. You have to pass through those points. So the only logical place that that first curve that I'm going to draw could go is through my y-intercept, through my x-intercept, to the horizontal asymptote. It should still look pretty similar to what we did with the parent function. The only reason I put it in the bottom section is because that is where the intercepts are. And I have to pass through intercepts. And I'm going to draw it, but I don't want you to draw it because I don't want you to write it wrong on your paper. If I had put the curve up here instead, I would miss those 2 points entirely. And also, another problem with this is I would be crossing the y-axis in a place where I don't have a y-intercept. You cannot do that. You can only cross at intercepts that you have found from the equation. So that is a bad place. Now, what did we say about the arrows? What do they have to do? The opposite. So if my arrow is going down on the right, what does it have to do on the left? It has to go up. So the only place that this curve could go is in the top section, because they need to be going in opposite directions. Now, the other kind of thing that I'm going to tell you as to why the bottom section is wrong, if I came in and drew a curve here, 2 things are a problem. 1, my arrows would be going together, and we do not have togetherness. You will not have togetherness at all today. 2, I am crossing the x-axis at a place where I don't have an x-intercept. You cannot do that. It's like a gate. That is the only gate you can cross through, is where you have an X and a Y intercept. So it cannot fit in the bottom section. It has to go in the top. Yes, Ite. Well, it can't go on the top, so it has to be one curve per vertical section. So like I can't have two curves in line with each other. And I said it couldn't go in the top because I would be missing the x-intercept and the y-intercept on the bottom. You have to pass through the points that you have. Okay. Other questions? We're going to practice. We're practicing quite a bit today. So let's try another one. Example 2. Step 1, remember, is going to be that you factor. So what do we notice about the numerator? It is factorable. It has a what? X is a GCF, right? So let's pull out an X. X plus 2. Denominator. If I wanted to factor the denominator, what multiplies to be negative 18 adds to be negative 3? Negative 6. Positive 3. That is how fast you should be factoring, if not faster. Whenever we go through, because remember, if you cannot get past the factoring step, you cannot do anything else. That is step 1. You have to be able to factor. If you are not the best at factoring, it's time to get on IXL and start practicing your factoring because you have to do this quickly. We've done factoring in this class multiple times at this point. So roots come from the numerator. I should have 2 of them. I have x equals 0 and I have x plus 2 equals 0. So whenever we get x equals 0, that just means one of my roots is at 0, 0. So I'm going to go ahead, put that down. What would I get from x plus 2 equals 0? Negative 2, 0. So I'm going to have negative 2, 0. So I'm going to go to negative 2, 0. I'm going to draw a point. Asymptotes come from the denominator. So I'm going to take both factors that are in the denominator. X minus 6 equals 0. X plus 3 equals 0. And I'm going to get 2 vertical asymptotes this time. That means when I go to draw my curve, I'm going to have 3 of them. So I will have one asymptote at x equals positive 6. I will have one asymptote at x equals negative 3. And so these are what we draw as vertical lines. So I'm going to draw one through positive 6. I'm going to draw one through negative 3. For the sake of today, you guys will not be seeing any tangency or togetherness, so I'm just going to write no tan, no tog. If it's helpful to you to draw a picture that says, okay, we need to be going through the points and we need to be having arrows in opposite directions, that is something that you can have there as a point of reference back to how am I supposed to actually graph these things. Now, end behavior is going to have us look at the highest exponents in our numerator and our denominator. So I kind of like to go in and rewrite standard form, and it may be even helpful. I'm going to write the whole thing down here just so that we can use it for e and y. X squared plus minus 3x minus 18. The reason why I want both things, so if I look at my highest exponent, it is a squared over a squared. And we said if they are the same, all we have to do is divide the coefficients. If you don't see a number in front, the coefficient is 1. So because this is an eats DC, we're going to end up with y equals 1. Now, before you go in and you draw this line all the way across, E stands for end behavior. And when you have a problem where there are 3 sections, the end behavior is the ends of the graph. So I'm only going to draw my horizontal on the outside sections. Now, for the most part, if you draw it in the middle, it's not the end of the world. The only reason why I don't is we say that the asymptotes are lines you cannot cross, but you can cross a horizontal in the middle section because it's technically only end behavior. So that's why I like to leave it off. The y-intercept comes from the constants. So I have a constant of 0 if I look at my numerator, because it would be like plus 0 here. And so I have 0 over negative 18. What does that simplify to? 0 over anything is 0. So my y-intercept is 0, 0. One little hint here. If your x-intercept or one of your x-intercepts is 0, then your y-intercept is also 0 because that is where they meet. So I don't necessarily have to redraw this point, but I am just going to circle it so you guys know I did graph it. It's not something that you have to notate as something different on your paper. As long as we see that there is a point there, great, wonderful. We're giving you credit. Now, before you get freaked out by the curve part, you are getting most of the points. If this was like a 10-point problem, we usually only give like 1 or 2 points to did they put the curves in the right place after they did all of this work. So going in and doing this stuff is most of what you're going to get for these types of questions. Now, I truthfully find parts that don't have points as the easiest ones to kind of do first. If I look at the left-hand side, the left section, the left vertical piece, top and bottom, do I have any x-intercepts in that section? No. So can I put my curve in the bottom at all if there are no x-intercepts? No. So the only place that this one is going to fit is up here. Now, again, reasoning as to why for people who are like, well, why? If I were to put it down here and have it go through, I would be crossing the x-axis at a place where I don't have an x-intercept. You have to have an x-intercept to cross the x-axis. If you do not have one, it does not go there. So because I don't, it has to go in the top. Now, the next easy section is probably the right side. Should that go in the top or should that go in the bottom? In the top. I don't have any x-intercepts, so I cannot cross the x-axis in a place where I don't have any x-intercepts. So the only place this one is going to fit is here. Yes. Is that in my vertical sections that we're talking about right now? No, no. Are they going together at the asymptote? At the same asymptote? No, they are going together at different asymptotes. So now, kind of going off of that, we said that they have to go in opposite directions at the asymptote. So if they're both going up, the other direction on the other side of the asymptote means that it has to be going down. So you're looking at these as individual asymptote directions. So I have one going up, so the other has to go down. And then if I kind of slide to the one at x equals 6, I have one going down, the other has to go up. Hey. So because they are two separate things, we will treat them as two separate things. Eventually, when we get to describing togetherness, it will be at particular asymptotes, not just across the board. Okay, so we're both going down. Are we okay with our arrows going down so far? What's our questions if we're not okay? You don't even know your questions. Okay, so If I have to end up with both of my arrows going down, knowing that I have to go through my points, and eventually coming back down to my other arrow. You have to draw it, yes. How many asymptotes do I have? How many vertical asymptotes do I have? 2. And I always said you need one more curve than vertical asymptotes. So if I have 2 vertical asymptotes, I need 3 curves. I want you, if you need to visually see, this is one vertical section, this whole left side. This is one. So you need one curve in that vertical section. This is another vertical section. So you need one curve in this vertical section. And then there is one vertical section in the middle. One curve, yes. So every single time you have an asymptote, it's adding in another curve that you have to draw. You will only ever draw 3. 3 is the maximum. We're not going to make you draw any more than 3. But it will either be one where you have 3 sections, 3 curves, or it'll be one where you have 2 sections and 2 curves. One or the other. And this is why I, again, told you beforehand, we don't give as much points to did their curves end up in the right place, because it is kind of, it's like a puzzle. You kind of have to put all of these pieces together. We care mostly about, can you find all of these identifying features? Yes, the curve is important, but it's not going to be a make or break. You completely lose all of the points on the problem. A lot of them should be easy. It's usually the middle section that gives people the most trouble. Okay, let's go to the back. I want you to factor the numerator and the denominator. I'm going to give you 2 minutes starting now. 2 minutes. 2 minutes is 1 minute more than what you need. Finish? Mm-hmm. Tuesday morning and Friday morning. Probably not this week. Maybe Thursday. I might be able to stay after school on Thursday.
Can I go tomorrow during advisory?
Mm-hmm. If I multiply those two, I'm not going to get -3. So like -3 times -2 is +6. And I should be getting -3.
What about the bottom?
Let me see the bottom one. I didn't see that one.
Yeah.
That one's good.
Okay, good.
Okay, any volunteers for my top 2 factors? Not Zite, because he's already volunteered his factor answers. I need another volunteer. Isabella, you look comfortable. What do you got for your top 2 factors? X plus 1, good. Do I have a volunteer for my bottom 2? Leah? X plus 6, X plus 1. Okay. Do we notice anything about the numerator and the denominator? Something is what? Do any of them look the same? They don't have a squared. Yes, we factored it. X plus 1. We have an X plus 1 in the top. We did. Good. We have an X plus 1 and we have an X plus 1. Normally, if we are multiplying, what can we do with those X plus 1s? If they're the same in the top and the same in the bottom? We can cancel them. Yes, we can cancel them out. So you will cancel them out. So we are going to cross out X plus 1, cross out X plus 1. Here is my biggest piece of advice I can give you for anything going forward with a hole in your graph, which is what you're going to have. rewrite the problem once you have canceled out your factors. I can tell you many times I will have someone ask me, why do I have an x-intercept where my asymptote is? And that is because you did not actually cancel them out and you're trying to do the rest of FRATEY on a factor that should not be there. So the rest of FRATEY, the rest of the problem that we do is going to be on x minus 3 over x plus 6. Now, before we go on, we have to do something with that x plus 1. Look at your orange sheet. Look at the orange piece of paper you have. At the very top, we said for h, that's going to be like our wholes. It says set any factors that cancel out equal to 0 and solve for x. So we're going to take that x plus 1, we're going to set it equal to 0. And then it says you will plug the x value into the leftover factors to find the y value. So I'm going to take the x that I get and I'm going to plug it in. So we're going to go in and we're going to do that. So if I take x plus 1, and I'm just going to kind of write my work up here. If I take x plus 1 and I set it equal to 0, what do I get? X equals negative 1. Now what I need to do is I need to take that x equals negative 1 and I need to substitute it in where I see x. So I'm going to go in to find the y value and I'm going to have negative 1 minus 3 over negative 1 plus 6. If I have a negative and I subtract from it, what's going to happen? Is it going to become more positive or is it going to become more negative? It's going to become more negative. So what's negative 1 minus 3? Negative 4. If I have a negative and a bigger positive, it's going to stay positive. So what's negative 1 plus 6? 5. So my hole in my graph is going to be at negative 1, negative 4 over 5. And what I want you to do, because I'm going to get this question a million times, put a big old star next to it, highlight it, box it, something where you know if I have a hole, this is what I should be doing. Because this is one of the more commonly missed parts of this whole test, is going in and finding the value of where the hole should be. So now that I have the point, I'm going to go in and I'm just going to graph it. It's going to be an open circle at negative 1, negative 4 over 5. It does not have to be perfect. It's just something on my graph knowing I have to pass through it at some point. Okay, where do roots come from? What part of the fraction? The numerator. So I'm going to take x minus 3 equal to 0. So I have a root at where? But how do I write it? I don't write it as x equals 3. 3, 0. So it's got to be a point. On your test, if you write x equals 3, we will take off half a point. It has to be written as 3, 0. So I'm going to go in 3, 0. That's going to be my x-intercept. Where do our vertical asymptotes come from? Denominator. So my denominator is x plus 6. So I'm going to take x plus 6. I'm going to set it equal to 0. I'm going to get a vertical asymptote at x equals negative 6. So I'm going to go to x equals negative 6. And I'm going to draw my vertical. And we said, for the sake of today, you will not have any tangency and you will not have any togetherness. So I'm just going to fill that in. And I think on your practice today, we have it filled in for you. But basically what this means is we are going through a point, and at the vertical asymptotes, our arrows should be going in opposite directions. Now, I only have one vertical asymptote. So when I draw my curves, how many should I have? 2. One more than the number of vertical asymptotes you have. So if you have one vertical asymptote, 2 curves. If you have 2 vertical asymptotes, 3 curves. Okay, now for the sake of doing the E and the Y, It is beneficial, I think, to rewrite your problem down here just so you can kind of look at it as your point of reference, because you do need standard form for both in behavior and the y-intercept. For in behavior, you are looking at the highest exponent. And for now, again, remember we kind of told you you're only going to be looking at one case. Sometimes we'll do the bigger on bottom, but that's a little less popular. Same exponent, same coefficient. So my eats DC is going to be eats DC y equals 1. And this one I'm going to draw all the way across because I don't have a middle section that I have to worry about. All the way across my graph. Now for the y-intercept. The reason why I say standard form is really nice for the y-intercept is you only have to come in and look at the constants. So I have -3 over +6. What does that simplify to? -1/2. So my y-intercept is -1 over 2, 0. Oh, sorry, flip it. Wrong way, wrong direction. Y'all should have said something. Y'all have been writing y-intercepts since 8th grade, 7th grade. Since y'all learned what a slope of a line was. Okay, I'm going to draw -1/2 somewhere right here. Okay, we need to draw our curves. Now again, before you start freaking out about the curve part, remember, most of your points are coming from identifying all these features correctly and putting them on the graph. Usually in the end, your curves are worth 1, maybe 2 or 3 points. That is it. So I have 2 vertical sections, one on the left, one on the right. Left-hand side, I think, is easier. Should it go in the top or should it go in the bottom? Top, good. So it's going to go in the top because we do not have any curves or any x-intercepts whatsoever. So it has to go where it's not going to break any rules. If it was in the bottom section, it would be crossing where you don't have an x-intercept. You cannot do that. Now, because it's going upwards and we do not have any togetherness, we said the arrows have to go in opposite directions. So if this one is going up, then we know the other arrow has to be going down, which should be in line with what you're seeing from your points. So when I have that arrow going down, it's going to be in the same section that I have my x-intercept, my y-intercept, and my hole. Yes, Ite. Do I have any x-intercepts in that section? No. So can I pass where I don't have any x-intercepts? So then it has to go in the top. If I put it down here, I would be crossing at a place where I don't have an x-intercept. And I can't do that. You can only cross where you have an x-intercept.
I mean, like, how do you know the arrow goes in that way, like not flip?
It will never go the other way. Never, ever. You always have to get close to the asymptotes. So if I put it, I'm going to show you what I think you're thinking of. If I put it like this, no, just wrong. Just wrong. Not a good one. Have we ever drawn anything like that? No. You have to get close to the asymptotes. Okay, so for the other one, our arrow is down. We have to go through the hole. We have to go through the y-intercept, through the x-intercept to the other horizontal. Okay, the next one. I'm going to factor with you because you may have forgotten how to factor this way, and if you have, that is not the best, but we'll review. Can I use the shortcut on the numerator? No. Why can I not use the shortcut on the numerator? A equals 3. You have to go the long way. So I'm going to go in And I'm going to see, I need something that multiplies to negative 12, adds to positive 1. What would that be? Not 6.
4, 3.
3 and 4. One of them has to be negative. Which one?
3.
The 3. Negative 3, positive 4. There we go. So when you factor in this way, you have to split the middle term. So I'm going to write this as 3x squared minus 3x plus 4x minus 4. The reason why, again, just to cover all of our bases, this negative 3x plus 4x is replacing this plus x. So whenever you have to factor the long way, you have to group the first two terms. So group the last two terms. What is the GCF of my first group? 3x. So I have 3x, x minus 1. What is the GCF of my second group? 4. I always include the symbol, just for my people who do this and then you're like, wait, why is my symbol wrong? I always put plus 4 so that I know when I write this that I'm going to get a 3x plus 4 term and not just some random 3x4 thing. When we do this, we should get our two factors, and that should be 3x plus 4 and x minus 1. So that is going to be my numerator. The denominator should work a little bit easier. It has a GCF. What is the GCF? An x. So I'm going to pull an x out, and I'm going to have 2x minus 5. Now that you know that there are holes in your graph, the first thing you should always do is check and see if something's going to cancel. In this case, nothing is going to cancel. So we are going to go in, identify our roots, our asymptotes, our in behavior, and our y-intercept, and do our graph. So I have two roots because I have two factors in my numerator. And so I'm going to take 3x plus 4. I'm going to set it equal to 0. I'm going to take x minus 1. I'm going to set it equal to 0. And when you write these problems, you're going to write them as a coordinate point. So I'm going to have negative 4 over 3, 0. Because I subtract 4, I divide by 3. And I'm going to have 1 comma 0. And if you end up with fractions, we're not going to be nitpicky and be like, oh my gosh, they put it looks like it's at negative 5 over 3, not negative 4 over 3. As long as it's in between the right numbers, we're going to assume you know where it's supposed to go. So when I have negative 4 over 3, 0, that's a little bit more than negative 1. And then when I have 1 comma 0, that will go directly on the point. I have two vertical asymptotes. Those are coming from the denominator. So I'm going to have x equals 0, which we don't have to do anything for. It's already solved. So I'm going to go in and have x equals 0. And then I'm going to have 2x minus 5 is equal to 0. So that's going to give me x equals 5 over 2. How many times does 2 go into 5? Twice. So that means I should be somewhere in between 2 and 3. You should be. We should know our fractions. Yes, we should. For the sake of today, no tangency, no togetherness. So tangency is bouncing off of a point, so going back in the direction you came from, which is why when I draw this picture, I'm pointing my line through the point so that it shows we're not going to go back in the same direction. And no togetherness means our arrows should be going in opposite directions. I do think it's helpful to rewrite your problem down here in the in behavior section, just so that you can kind of quickly identify. And if you're like, I can look up and not have to rewrite it, great, wonderful. but I like to kind of have it down there as a point of reference for my y-intercept. Always pay attention to the exponents, the highest degree. I have an exponent of 2 over an exponent of 2. That is going to be the same thing we've kind of been seeing all day. That is the Eats DC. So Eats DC means we are going to divide the coefficients. Now this one is unlike the ones we've done so far where they were all 1. This one is 3 over 2. So when I write my end behavior, it's y equals 3 over 2. You can leave it as 3 over 2. If you want to write 1.5, great. We're not going to require that you do that. I'm going to leave it as 3 over 2, but I'm still going to put it in between 1 and 2 so that I have my horizontal. I'm actually not going to draw it in the middle. I'm just going to have it on the ends. Now, for the y-intercept, this one's kind of a special case. I don't have a constant term on the bottom, so it's kind of like there's a plus 0 there. But we've talked about, can I take -4 and divide it by 0? What do we say if we are dividing by 0? It is undefined. So this means there is no y-intercept. Now, another thing that you can kind of do to connect the dots is our vertical asymptote is on the y-axis. You cannot touch a vertical asymptote. So if your vertical asymptote is sitting on the y-axis, you are never, ever, ever going to have a y-intercept because you cannot have a point on an asymptote. So now we draw. How many vertical sections do I have? I heard both answers. How many vertical sections do I have? I have 1 right here. So I have 3 vertical sections. So if I have 3 vertical sections, how many curves should I have? If I have 3 vertical sections, how many curves should I have? 3. 1 curve for each vertical section. Personally, I think the right-hand side is the easiest because there are no intercepts at all. So if there are no intercepts at all, you cannot be in a section that's going to cross an axis. So it cannot go in the bottom, it has to go in the top. So when I draw this curve, it has to go here. You cannot cross an x-axis or a y-axis at any point that you do not have an x-intercept or a y-intercept. Okay, and then I would say the left section is probably the next best one. I do have an x-intercept, and you have to pass through x-intercepts. So wherever your intercepts are, that is the section you need to be in. So since my x-intercept is on the bottom, I need to have my curve on the bottom. Okay, now we're in the middle. What did we say about our arrows before we start panicking? What about the arrows do they have to do? Opposite directions. So they have to go in the opposite direction. And they have to go in the opposite direction at each asymptote. So if it's going, I'm looking at the first one on the left-hand side. If it's going down on the left, it needs to go up on the right. And now I'm going to look at the asymptote at 5 over 2. If it's going up on the right, it needs to go down on the left. It can be an S, yes. So are we okay with the direction of our arrows? Opposite directions on the asymptote. And then you just connect your dots in the middle. It's going to kind of look like an S. Like a cubic almost. A couple of shapes just to kind of give you a basis for your middle section. It can look like a cubic. It can look like a quadratic. Those are kind of the two common ones we see. Okay. Questions about our graphing? All right, let's look at example 5. So we are going to create a rational function, and it's going to list a bunch of different features. The first thing you're going to do is you are going to write an equation. F of x equals a big old fraction bar. Big old fraction bar. Where did we say roots come from? Roots come from the numerator. So these 2 points will have to be shown in the numerator. Where did we say vertical asymptotes come from? The denominator. So I'm going to put this as my denominator. Okay, now horizontal asymptote, I wouldn't worry about just yet. The hole. How do we know if we have a hole in our graph? How do we know if we are given the equation that there's a hole in our graph? Go look at example 3. When we cancel something out. So I'm going to make a little note here that says same factor in the numerator and the denominator. Okay, so now we have to kind of take these values, and I'm going to do horizontal at the very end, and we have to turn them into factors that make the original equation. So if I got, looking at the numerators, if I got x equals -4, what factor did that come from? X plus 4. If I got x equals +4, what factor did that come from? X minus 4. So if we just said that our numerators have to go, or our roots have to go in the numerator, I need to put x plus 4, x minus 4 in the numerator. Same idea for our vertical asymptotes. If I got x equals 3, what factor did that come from? X minus 3. And if I got x equals 0, what factor did that come from? Just a single x. So that means an x in the bottom and an x minus 3. Now, the other additional thing that we have is a hole. And so if my hole was at x equals -1, and I'm going to keep trying to write these out so you can see them, what factor did that come from? If I got x equals -1, what factor did I solve? X plus 1. Now, the only thing about the hole is it has to go in the top and the bottom. So I'm going to put an x plus 1 up here, and I'm going to put an x plus 1 down here. So we've kind of met the criteria for 3 of these things. The last piece is the horizontal asymptote at y equals 3. Anytime it's a number, it is an EATS DC. So you need to make sure your exponents are the same, and then you just have to make the numbers in front be something that divide to that number that they give you. So what I notice is I have an x, an x, and an x in the top. So that is x cubed. And then I notice in the bottom we have an x, an x, an x. So that is an x cubed. So right now with the other factors that I've listed, I already have exponents are the same. And usually that's how it works out. So all I have to do is figure out two numbers, or even one number really, to put at the very front so that if I divide them, it equals to 3. Easiest one is going to be 3 over 1. 9 and 3 would work. 27 and 9 would work. But whatever numbers you pick at the front, just make sure that they divide to be 3. And that is your answer. You do not have to multiply these out. Please, please, please do not multiply them out. Leave them in factored form. Do not waste your time. That is it. Okay, I'm going to give you your practice